Hey guys, I'm gonna do a video here on the large volume nebulizer. Okay, so we'll talk about what a large volume nebulizer is, some of the common indications or situations in which we find ourselves using them, how to kind of build a circuit, and then talk about a little bit of miscellaneous stuff here. Okay, so humidity, like with the bubblers, is invisible. It's water vapor, right? We can't see it. Now with aerosols, which is what a large volume nebulizer actually is creating, not that there's not humidity involved in the process, but an aerosol is actually water particles suspended in a gas. So the idea with bland aerosol therapy, meaning non-medicated, okay, is we are ultimately blanketing the airways with a aerosol of, sterile water for inhalation. All right. So these patients, they're getting moisture down into their tracheobronchial tree to keep secretions moving, make sure everything's kind of nice and moist and preserving the function of the lower airways. So these come in a couple of different designs. Okay, ultimately we have sterile water for inhalation. I have a tiny bottle, so this is a 500 milliliter. Usually we'll have at least like a 1 liter bottle. Okay, supply chain stuff, I had to kind of take what I can get. So these bottles, we're not just filling up from the tap or anything. We'll usually have an abundance of replacement bottles just with a lid. Now, ultimately, we have this piece that drops down inside of that water bottle, okay? And if you look up top, it's really just a big Venturi system. So I have the ability, there's a little line right there, okay? And there's little lines that link up with different FiO2s. So, we know that with air entrainment, I can either change the diameter of a jet nozzle, or I can change the size of an entrainment port. You can see I got an entrainment port right here, and as I'm changing my FiO2s by just turning this little blue piece, I'm changing the size of that entrainment port, okay? Now this one's misleading. It goes all the way from, up to 70 and 100%, which we know there's gonna be some problems with that if you start talking about and thinking about air entrainment and the problems we have with those higher FiO2s. We got a disc connector here that's gonna be able to go ahead and thread onto our flow meter. Generally, medical oxygen, but there's times where we use medical air. Our patient doesn't need O2. So the way that this works, okay, still goes through our little jet that's got a fixed diameter. All right, same thing happens with air entrainment, but with that lateral pressure drop, we got a little piece here that's able to draw some of that sterile water from the bottom of this bottle, all right, and inject it into this gas stream. And as we get those water particles hitting that gas stream, we get a shearing of these forces, and that's what suspends it in a actual gas, and we create an aerosol with these large volume nebulizers here, okay? So it also has what's called a baffle if you start looking through there, and it ultimately just slows down the big particles that are gonna not have any chance of actually making it for the patient and drop back into the water chamber. You'll be able to see that when this thing's running. So this just drops down and in here. We're going to thread it on, making sure that you haven't cross-threaded anything. You're going to pick your FiO2, so we'll go ahead and go. So all the stuff you learned with air entrainment Venturis before, calculating the ratio and figuring out what you need to set your input flow at to make this, truly high flow or get to our target of 60. All of that still holds true. It's just a different way of setting the FiO2 on this particular device, okay? Now, as we get this thing set up and running, I'll tell you, everything as far as meeting or exceeding that patient's flow requirement before was something that was theoretical. We picked 60 and we talked about where that 60 liters a minute of total flow comes from. With having an aerosol, we have a different little trick we can kind of use here, okay? So these thread on, same deals I've warned you about with the bubblers. Anytime you're threading plastic onto metal, we're worried about stripping that out. So if I can't get it to go on really easily, I'll pop that flow meter out. Make sure it goes kind of nice and easy, okay? You don't need to death grip tighten it. If it's not going, something is wrong, okay? You're trying to get it cross-threaded, and then this just ultimately hooks on like this here. And hang on a second, I think I got a broken part. Let me grab one thing, I'll be right back. All right, sorry about that. I had a little bit of equipment difficulty, so I went ahead and grabbed a different piece. Sometimes students are a little rough on things, and part of the piece of plastic that attaches all this was cracked in it, so I could tell by that sound that there was something going wrong. So I got a liter bottle, same hookup here initially, okay? So I got this, have it set at 30%. All of our gas is gonna come out right through here, okay? So you notice this is a different diameter than everything else we've talked about up to this point. So some of the standard connection sizes in respirators I've kind of alluded to in lab, we utilize a lot of things that are either 22 millimeter or 15 millimeter, okay? This particular piece has got a 22 millimeter outer diameter attachment or outlet, okay, that allows us to put something called corrugated tubing on there, or large bore tubing, okay? And we use this stuff a lot in respiratory care. So I'm gonna go ahead and put this on. So once again, if I'm having trouble, pop that flow meter off and throw that thing on directly and pop it back in. So as far as making connections, some places you'll have one ginormous spool of 100 yards of this stuff and you're cutting pieces off. Other places you can buy kind of prepackaged little pieces of this stuff. If I'm trying to cut this off myself, okay, what I generally find, I'll try and trim this stuff up back in the apartment. If I get about enough, so we're gonna need 2 pieces, and I'll kind of show you why in a second. 2 pieces that are about my arm's width apart, okay? If you're shorter than me, most people aren't, you can make it a little bit longer. Likewise, if you're taller, maybe a touch shorter there, okay? And we're still gonna have to trim some stuff up when we get back to the patient's room and kind of look at everything. It is important to note that if you have to trim this stuff, if you look, there's a little line right here in the center. You want to make sure you take your shears and cut right along that line. If you cut it off to the side here or there or back here, you're never going to be able to easily get that on these 22 millimeter connections, okay? You're making life way harder than it needs to be. If you cut it pretty nice on this line, you can see whoever cut this one didn't do a great job, a little crooked there. It's going to go on just so much more simple. So we're going to go ahead and put this piece on. If you did your air entrainment ratio, okay, 100 minus 30 is 70. All right, we have 30 minus 20 is 10, so you got 70 to 10. Divide each of those by 10, okay, and you end up with 7 to 1, so 8 parts. We need 60 liters of flow ideally, so if you divide it 60 by 8, you end up with what, 7.5. We're just going to round up and run a 30% at about 8 liters a minute. All right, input flow, and that should get us close. It's hard to see in this video, okay? You probably can't see it very well, but I'll try and show you kind of with that monitor as a backdrop. Venturis and air entrainment, they rely upon there not being any downstream resistance or backup and pressure in order to entrain air and work the way they should. So we don't want this stuff building up in our tubing and causing problems. Even more importantly, when we start adding Kedon with something I'm going to show you here in a little bit. So the reason we need 2 lengths of tubing is because we're going to take a drain bag, okay? I will tell you, make sure these drain bags are closed. This is a pretty large one. They come in different sizes, okay? So once I get that closed, it's going to go into this Y on one end. Same deal. So I got a 22 millimeter, all right, internal diameter. All these things it's meant to hook to are 22 outer, so it slides on nice and easy. All right, and then I'm going to take another piece of tubing, same length, all right, and hook it on like this. Now these drain bags, you don't want to go through all the trouble of putting a drain bag to collect condensate and then just throwing it on the ground and the thing be upside down and bubbling in your circuit, okay? So most of these come with either like a hook design to be able to put on, and you can clip it into the lowest point in the system, so you can clip it to the bed rail or something like that. They make some other ones. They make some other ones that it's just like this little piece of plastic and it slides through, and then you can kind of snug that up and run it through this top piece and loop it onto the bed. Okay, so you want this being in a downward position, and you want it being really in the lowest point of the system. Otherwise, water builds up and it's not really serving its purpose here. Every facility is different. I know most facilities I have, we'd either change these out daily or every 2 days, every 48 hours. So usually if I'm changing it out, I'd initial and I'd put the date that I changed it. Okay, I prefer to put the date and time that I changed it rather than the date it needs to be changed, in case the next shift is running behind. You don't want a family member to see something and get upset or anything. Not that, you know, we shouldn't be changing these, but trying to kind of look out for your crew, very, very important. All right. Now, It's hard for you guys to see from this view, but this thing is quite long still, okay? So if my bed was hooked up right here, I don't want this tubing really, really long. A lot of times that first line, I'll cut extra short, all right? Especially if the patient's not getting up and out of bed, I'll cut some slack off of this, and then that leaves this kind of in that upright position and with no chance of it getting turned over or anything like that. So I do make some final connections and trimmings once I get back to the patient's room, get them hooked up, and kind of size up all my distances that I'm having to clear and everything like that, okay? So let's talk about appliances here, okay? So I'm going to show you the different things that we can attach to this, the most common ones at least, and then we'll talk about how to add on heat, okay, in situations in which you would heat that and in which you would not. Now, probably one of the least seldom, at least in my experience, one of the least seldom things we hook this to, but you can, would be an aerosol face mask. So you can see we got the bigger holes here on the side, we got the 22 millimeter outer diameter connector here at the outlet, and we can hook something like that straight on, okay? I want to point out with all of these masks, you got just a simple elastic band that you're pulling through an opening to kind of snug stuff up on a patient. These particular little simple knot in the tag end of that. That way it can't pull out. If you pull this out too far when you're taking it off a patient or putting it on, it is about impossible to put back on without a lot of effort, okay? So I usually will go ahead and just tie a knot at the very far end, and it's usually big enough for, way bigger than most people's heads, okay? And I got a ginormous head. So you can go ahead and do that so it doesn't get pulled out. So we got the aerosol face mask, okay? You put that on their face. You got the bigger hole so you don't get a bunch of resistance or anything like that. You can kind of contour that piece of metal under their nose. Sometimes we'll have people that don't, like a lot of times if you have a patient and you're doing this and they're in an inhalator, like smoking a cigarette on a nasal cannula and their nose is burned, we're trying to humidify stuff, you can't have a nasal cannula, and they don't want to wear a mask or something like that because it's maybe rubbing. We have the face tint. Okay, you can see the face tint. This particular one has a hard fixed 22 millimeter outer adapter. Some of them do come with something like this where that adapter can accidentally come out, okay, and then you need it to hook back in. So kind of be careful if you're pulling that thing up and out of there. The face tint, although it doesn't seem as effective because this is high flow, it's directing a ton of gas up right at that patient's nose and their mouth, okay? I've used this, once again, a lot of cigarette smokers on oxygen, they get burned and melt a cannula on their face. I've used this on like croup kids and things like that as well. All right, the biggest thing I'll tell you about the face tint is people put this thing on wrong all the time, okay? So think about it, you can see gas coming up right through here. Where do we want gas? We want that gas shooting right up to my nose and my mouth and kind of enveloping my face, so to speak, okay? You can see it's coming right up into my nose and my mouth, and I get a big cocoon of oxygen and aerosol and humidification kind of all around me. I probably shouldn't be breathing this. This actually isn't sterile water. The thing people do wrong, and I've never understood it, is they'll do it like this, and you'll come in and you'll see the person's, in my case, my beard would be dripping with water. I'm not really fully getting that gas. And likewise, I don't have everything up around my nose and my mouth, so it's a little bit more difficult for me to truly ensure that I'm getting what I need here, okay? So always make sure you think about where that gas is going. I don't know if you can see that kind of aerosol cloud here. The good thing about aerosol, we can tell if somebody's getting enough flow or not if you look really, really closely. As long as the amount of aerosol coming out of the device doesn't completely disappear on inspiration, it'll slow down. But as long as you still see more coming out than what I'm taking in, you know that you're providing high flow for that moment in time. So when you show up and you see a patient in a situation, I'm trying to look at that aerosol. If you don't see enough aerosol coming out of there and it completely disappears on peak inspiration, it means you are not providing more flow than what they're taking in. And in that moment in time, they're drawing in the rest of their gas they're taking in is from room air, so they're actually diluting down what you think you're giving them, and it's no longer high flow or anything. So very, very important. Sometimes it's difficult to see depending on the lighting in your room and things like that, but you get a visual to kind of link up with these concepts, okay? So what are some other things we can hook to? So the two other kind of common ones, we have a trach collar or trach mask, okay? So you notice how that thing is kind of cut on a bevel or an angle. People put this thing upside down, okay? There is writing on there, so you should be able to see clearly, you know, and the writing's always going to be kind of in an upright manner here. So people have put this trach collar on wrong, but really it's supposed to sit kind of the way the chest is. Sit right up over the trach, and kind of snug that up here. You do have a snap button since we're having to run this back behind somebody's head. Okay, so the other ones, they're kind of fixed on both sides, but you still have that kind of tag in. If, in this case, especially when you're looping these behind people's head, I'd recommend kind of tying a little knot in the end here so somebody doesn't pull that out. I'm going to do so kind of here right now. You can see it doesn't have to be anything crazy. It's just so that doesn't get pulled out here. You got a tiny little exhalation port here, okay? Same deal. This is just going to kind of sit over their tracheostomy, and you kind of go ahead and tighten this up a little bit, and it kind of sits right on their trach. So let's say we got a patient with a ton of secretions. We can use something called a Briggs adapter or T-piece. So I'll be real with you, we don't really commonly use the Briggs adapter a whole lot anymore, okay? So the Briggs adapter and the T-piece are for use for artificial airways. So you either got an endotracheal tube or more commonly a tracheostomy tube. So it's talking about standard diameters. This tubing is 22 millimeters, internal, and it hooks up on all the things we've been talking about. Artificial airways, regardless of the size, most of the standard airways are going to have a 15 millimeter adapter, all right, OD, or outer. So a lot of the things that hook onto an artificial airway, we actually have the ability to have a 15 millimeter internal diameter here, so it hooks onto a tracheostomy tube. Okay, and I'll show you more about trachs in the next semester, so you don't got to worry about that stuff. So a Briggs adapter is just pretty much a T-piece. Okay, so the bottom piece here, in this case the one with the little ribs, would go straight onto a tracheostomy tube, so there's no straps around the neck or head, hooks right onto an artificial airway. The supply from your large volume neb goes on one side, and then we use this little 6-inch piece of flex tubing. You could cut a slack off of this one is a different color, okay, came from something different, but all we need is open it, 6-inch flex. And it hooks on right here. That 6-inch flex serves as a reservoir, okay? So just in case a patient briefly exceeds whatever flow you have coming out of it, we're housing what, another 50, 100 mils of humidified, high FiO2 gas or whatever we have set right here. So in this particular case, you got a patient hooked up like this, and it's great. You had that ability to hook straight under their airway. They're getting all the gases they're breathing by. As they exhale, it shoots it out the little port right here. Now the problem with Briggs adapters, besides that we don't commonly use them, I still got to pop a patient off to suction them, and then they're not getting any oxygen or anything like that, okay? Anybody with an artificial airway, we're going to have to suction them or check or pass something on the tracheostomy tube or ET tube at some point, all right? So the other problem with these is if you got somebody with a really good strong cough that's actually clearing all their own secretions, if you're not monitoring these patients, you can actually fill that tubing up with secretions, okay? So if I have somebody on a T-piece for frequent, with a lot of frequent suction, and first off, I'll try and consider them for a trach collar if they're clearing stuff on their own. But if they need a lot of suctioning and they're on a T, all right, you want to make sure it's kind of draining down so it doesn't occlude. But what I'll show you is if somebody's got a bunch of frequent secretions and we need to suction, something called an inline suction catheter, all right? So an inline suction catheter is meant, I'm going to wear this around my neck here for a second. An inline suction catheter gives us a reusable sterile suction catheter that we can advance down a patient's airway and clear them out. This is a shorter one. It's for use with a tracheostomy tube. All right, we can hook suction up to this end, and we have a little button, and we can direct vacuum pressure to the tip of this, okay? And we can lay on and pull a bunch of goobers out of there. So you can see we got a similar design. It's a T, okay? We got another little swivel adapter, take some of that airway torque off. It's just 15 millimeters, so it goes in right like this. This will hook onto a patient's trach right here, okay? We use these a lot for inline mechanical ventilation. So in mechanical ventilation, we have to maintain a closed system, and inspiration and exhalation is all happening through the machine. I got a cap on one end, so this would hook up to a ventilator circuit. A breath would go into the tracheostomy tube, come out, and go back through here and be exhaled out through the machine. Now, if you're doing with this with a tracheostomy collar, okay, we actually need an open system. We need a place to exhale. So if you get in a hurry and you put this on a patient, you hook it on a tracheostomy tube, you're going to start building up a whole lot of pressure. You'll hear a very distinct sound here, and sometimes water's shooting out. Your patient would ultimately be rebreathing carbon dioxide, and eventually it could possibly suffocate, okay? And it's going to compromise the way that this machine works here. So if you're taking a patient, you already have an inline suction, we're going to take this little white cap off the side, and we're going to take this little piece of flex tubing and hook it up like that so they got a place to exhale, okay? It needs to be inline suction that we're turning into a T-piece. You can do the same thing with an ET tube, endotracheal tube. It's not something we do as commonly or anything like that. And then once again, the benefit of doing this is we have the ability to continue to give them gas as we're going down and suctioning them, okay? And gives us the ability to do frequent suction without having to do open sterile suction all the time. But I would urge you, if you got a patient who's clearing a ton of secretions on their own and doesn't need to be suctioned, don't put them on this because they're just going to fill the tubing up. Put them on a trach collar and put a little wash rag underneath their trach, and it's going to be far better. All right, so that is really the last of the different airway appliances. Let's talk about a couple of other things here. So why would we provide bland aerosol therapy? Something can be to condition the airways or provide more moisture for somebody with a lot of thick secretions. All right, it can also be used commonly for swelling. So you got subglottic edema, you got croup, you had just some sort of surgery done in your upper airway, and we're trying to keep things nice and kind of moistened up by depositing the sterile water mucus blanket on there. We got to know why you're being on this, because if we have you on it for secretions or clearance and everything like that, we need to seriously consider adding heat on, okay? So there's going to be some times where we always have to add heat. Likewise, if you're using this for swelling, heat is going to make swelling worse. We would not want to use heat if you're using this for somebody with some sort of airway swelling. All right, so how can we add heat onto this? So this particular design here, and I'm going to go ahead and I'm going to turn this off here for right now. Okay, you wouldn't want to leave your patient hooked up for this. These particular ones, we use what's called a yoke heater. Nobody calls it that. It's a donut heater. And ultimately, we grab a little plug-in heater here. This slips right over the top. It heats the gas up as it's going through this device, and it can provide a little bit of heat. Now, temperature, adding heat to the system greatly improves the amount of moisture that gas can hold. All right, so if we're trying to fix somebody with a secretion issue and thin out that mucus, keep everything going well, make sure we're conditioning their lower airways and they have that gas fully conditioned and appropriate for them, we need to consider adding heat on. Now, this one is a very basic one, and it doesn't give us the ability to adjust the temperature. But because of this corrugated tubing that we're using, all right, gas cools off, and as it cools off, you're going to get condensation, and as we get condensation in this system, back pressure can compromise the way an air entrainment device works. Okay. Likewise, it's very difficult to truly ensure that we're delivering 37 degrees Celsius, gas to a patient, and especially with something like this where we can't adjust the temperature. So these are not as effective as some of your other options that I'll kind of get into. So we slide this on. I do want to point out most of them have like a silicone sleeve over it. You want the silicone sleeve kind of on top because that's going to be where you can burn your hand, kind of snugging this thing off. So I'm going to thread this thing kind of back on here. I'd plug this on the wall, and usually they'll have some sort of a lighting system that lets you know that the thing's on. So you can see my little green light there. Now, the problem with these is, once again, not as effective as something that can allow us to achieve a certain temperature and maintain that temperature the entire way to a patient. Okay, so if all of a sudden my bottle goes dry and I haven't been checking on my patient, usually you're keeping tabs on this patient all throughout your shift and they're on your patient care list. If this bottle goes dry, now I'm giving a hot dry gas, which is worse than just giving a dry gas. Okay, it's going to be more. Now, if we did have an adjustable one, and we could adjust the temperature of the gas coming out of this, we don't care how much the gas temperature is right there so much as we do as it's getting closer to the patient. So we on a means of checking the temperature close to the patient. You just take another little T-piece or Briggs kind of adapter here. You take a little thermometer, put it. You would need another piece of tubing, and it doesn't have to be right there to the patient, but you want it pretty close to know what they're getting. Okay, now we can monitor the temperature of that gas kind of coming out of this device. It's going to cool off as it gets further away because this tubing has no of our other systems. Okay, so let's talk about some other situations in which you would want to add heat. So if you have a tracheostomy tube, we automatically have to add heat. So always add in heat for a T-piece or a trach collar. All right, so that's always something you need to keep in mind. If you have somebody that has hyperreactive airways, so somebody with cold weather induced bronchospasm or something, you want to be very leery about putting them on a cool, bland aerosol. Not that it's not going to blink their airways with moisture and everything, but that cool gas can cause them to go into bronchospasm. So somebody with historeactive airways, you need to be very cautious about something like that. Likewise, swelling, we would never add heat on. So you got people with post-extubation subglottic edema. You got somebody that just had a sinus surgery done or something, and you're trying to give them a face tint, you know, kind of moisten everything up and keep the swelling down. Don't add heat. It's going to cause problems. If you got somebody with major secretion issues, add heat. That heat is going to help the moisture carrying capacity of that gas hold more moisture and deliver more moisture to their lower tracheobronchial tree, okay? We have to be careful though if we're adding heat, especially with an adjustable, and you don't want to give gas to the patient that is too hot. All right, we don't want those secretions to just completely swell and give them a much higher gas than body temperature, because we could run into some problems with that. Okay, we'll also talk about some issues in regards to being able to get enough total flow on these higher FiO2s, okay? Now remember, these are back pressure compensated flow meters, so if I had to go up to 40% FiO2, I'm just turning my bottle here, we know my entrainment ratio changes. So now I have a 3-to-1 ratio, 4 parts. I gotta set this at 15 liters a minute. Because there's so much back pressure, especially here where I'm not truly having the same sophistication of a constant 50 PSI gas source like I would at a hospital, I can't get above 10 liters a minute. So I got to be able to figure out how much total flow is coming out of this device. If you think or not. Well, is aerosol disappearing on peak inspiration for my device? If it is not, I'm good for that moment in time. If I show up and evaluate a situation, well, I need to be able to think about that and realize that it might be a problem with flow, not necessarily something going wrong with the lungs, and I got to have a couple tricks up my sleeve with these particular devices. Big mistake that these people made when designing these devices, okay? If you ever turn your flow off on this, even if the patient's coming off for a little while, you want to make sure you turn that, okay, this thing can get really, really hot on it. You can see they let this bottle go up really high. You'll get a lot of calls in your career where, oh, they're desaturating. I've even followed therapists that do this. I bumped them up to 70% FiO2 or even 100%, and their sats aren't improving or anything. We got to think about the entrainment ratios associated with that. And ultimately, what I'll tell you is the higher we start going above 40%, the more trouble we're going to have delivering this as a truly high flow format. And once again, we'll talk about a way to navigate through this, although rather rare. Okay, we'll talk about a tandem and a bleed in, but we'll also talk more about some of these servo-controlled heated wire circuit high flow devices that are a much better option for your patient when you have the ability to do so. They're a little bit more complex though. Okay, so I hope that helps. We'll talk about some other stuff regarding these in our lab time in the coming weeks here. So take care.